What's up, Simpsonites? Got another Sim Science video popping off right now, live. Here we go. Talk about acids and bases. Okay, a topic we gotta get in here before we start reviewing. So, acids and bases. Here are 8 questions that by the end of this video you should understand the answers to. Okay, so you might want to write these down. Take a picture, screenshot, I don't know, something like that. But we're going to touch on all of these as we go through. So we're going to talk about pH, what it is, how we use pH to identify if something's an acid or a base. And then we'll move into talking about what an acid is and what it gives off in solution. And then what a base is, what it gives off in solution. Then what makes something a strong acid or base, what makes something a weak acid or base. And lastly, we're going to add a new type of reaction. So we already have the 5 types of reactions that we learned before, 4 or 5, I think it's 5, and we're going to add on one more. So let's look at the pH scale here. So you've probably heard the term before, pH scale. All right, so the pH scale, pH is a measure of acidity or basicity. It goes from 0 to 14 with 7 right in the middle. So what is pH? Well, what pH means, or what the P means, is negative log. So I don't know what level of math you guys have done, but P means negative log of the concentration. So the H is the concentration of H plus ions in solutions. So hydrogen ions that are in a solution. pH is a measure of how many hydrogen ions you have in a solution. Okay. So pH is a measure of hydrogen ions in solution. Okay, that's what it does. That's what we use pH for. And it's a scale. The pH scale is something we use to measure or identify how acidic or how basic something is. Now, this H plus can also be H3O, hydronium ions. So these are kind of interchangeable terms when we talk about pH, and we're going to talk about why that is here in a second. So that's what pH is. This is the pH scale. So a pH of 1 to 6 is acidic, and a pH of 8 to 14 is basic, with 7 right here, this is an arrow, being neutral. All right, so anything from 6 to 0 is acidic, anything from 8 to 14 is basic. And the further you go this way, the further you go towards the ends, the more basic something is, or the more acidic something is. So increasing acidic character, increasing basic character. Something with a pH of 1 is more acidic than something with a pH of 3. And something with a pH of 13 is more basic than something with a pH of 9. Okay? And then you can see here that the brackets mean concentration. So it's the concentration of hydronium ions, like I said right here. Hydronium ions. And it's a base 10 system, so you see that all these 10 to the different powers, telling you how much you have in a solution of this. So the more hydronium ions or H plus ions you have, the greater the number, the more acidic it is. The less hydronium ions you have, like way down here where it's 10 to negative 12, 13, 14, the less hydronium ions you have, the more basic it is. Okay, so acidic pH is from 6 to 0, and basic pH is from 8 to 14. Neutral pH is 7. Okay, so that answers our first 3 questions. Now let's talk about what an acid is and what it gives off in solution, what a base is and what it gives off in solution. Okay, so we're going to get to this in a second, which talks a little bit about acids and bases, specifically strength of acids and bases. So an acid is something that gives off H plus in solutions. Acids give off H plus. Okay, so that's why an acid starts with an H almost always. So you have acids like hydrochloric acid, which is hydrogen bonded to chlorine, hydrofluoric acid, hydrogen bonded to fluorine, et cetera, et cetera. Something with an H is going to be an acid. Okay, bases give off OH, hydroxide ions. So bases have OHs in them. So you'll see bases like potassium hydroxide, sodium hydroxide, et cetera, something with an OH that it can give off in solutions. Now, the reason that H plus and H3O plus here are interchangeable is because, well, what's going to happen if you take an acid and you put it in an aqueous solution? So if we take HCl and we add it to water, this is going to make chlorine and H3O. Okay, so this hydrogen here got added onto this water and you get H3O. So it's releasing H plus into the solution, but that H plus is then going to bond to water and form H3O plus. So that's why we use both of those terms interchangeably here. And then OH is going to form water in a solution, or no, I didn't say that right. Don't worry about that. Bases give off OH. So just remember that. An acid is something with hydrogen that gives off hydrogen in solution. So we identify acids by identifying these hydrogens. Bases have OH and they give off OH in solution. So that answers what is an acid, what is a base, and then what they give off. So their identity lies in what they give off in solution. Okay, now we have this reading that you have in your notebooks. Okay, it talks about different strengths of acids. So we have HCl right here, which is an acid, hydrochloric acid. Then we have vinegar, which is also an acid. Okay, so you have the H out here in that case. Now, normally the H is out front, but acetic acid is a little bit of a different example. And you have to know the structure of it to be able to identify that, but don't worry about that too much. So they're both acids, but, vinegar you can use in food, whereas hydrochloric acid, it would kill you. So what makes something a strong acid or a strong base? Well, the strength of an acid is determined by how good it is at transferring H plus ions to a water molecule, how good it is at dissociating. So, like we said, pH is a measure of H plus ions or H3O plus ions in solution. So for something to make something more acidic, it has to give up that H plus more easily. Okay, so something like HCl, a strong acid, gives up its H plus really easily. It dissociates easily. HCl is easily broken up into H plus and Cl minus when you put it in water. Okay, a weak acid, on the other hand, like vinegar, is not very good at transferring H plus ions to water. Okay, so a very small amount of the molecules react with water and form H3O plus. Okay, and that's because the bond strengths in this molecule are stronger than HCl. They're holding those bonds on tighter. Okay, so most of those acetic acid molecules are going to stay intact and they're not going to separate. So strong acids and bases, so we were talking about acids, but both of them dissociate readily in water. Okay, strong acids and bases dissociate readily in water. Weak acids and bases don't. Okay, so here's a little chart of strong acids and strong bases. Up here we have strong acids, then weak acids, and things that are pretty much neutral. Then we have weak bases and strong bases. Okay, so the stronger the base, the more easily it separates the OH from whatever it's attached to, and the stronger the acid, the more readily it separates the H from whatever it's attached to. Okay, I think that's all I wanted to say about that. So the last thing is neutralization reaction. Neutralization reaction. So this is another type of reaction that you might see or be asked to identify. A neutralization reaction occurs when you have an acid plus a base creating a salt and water. Okay, so what does that mean? What's a salt? A salt's an ionic compound, a neutral ionic compound. So you've probably heard the term neutralization before. If you have a strong acid, you need to neutralize it with a base. And when you combine a strong acid and a base, you're going to get water, because the H plus that's released from the acid and the OH that's released by the base come together. And what do you get? You get two H's and one O, you get H2O. Okay, and then the things that were attached to the acid and base combine to form the salt. So an example of this would be if we took hydrochloric acid, HCl, reacted it with NaOH, sodium hydroxide, a base. That's going to create NaCl plus H2O. So it's sort of like a double replacement reaction, kind of. But you see you have the acid, you have the base, and you have them combining to form a salt, an ionic compound, and water. So when you see that, something with an H, something with an OH reacting to form a salt and water, you have a neutralization reaction. So that's another type of reaction that you may have to identify on a test. All right, that's about it for this. Make sure you have that all in your notes. Make sure you have each of these questions answered in your notes. So pH is a measure of H plus in solution. Acidic pH is 0 to 6. Basic pH is 8 to 14, neutral being 7. Acid is something that gives off hydrogen ions in solution. A base is something that gives off hydroxide ions in solution. A strong acid or base dissociates readily in water, breaks up readily in water. The more readily it breaks up, the stronger it is, the better it is at making that solution acidic or basic. A weak acid does not dissociate readily. And a neutralization reaction is where you have an acid and a base combining to form a salt and water.